All right. Hello. Hi, everyone, and welcome to this live DevSecond 2021 session. And this talk is about infrastructure as code, DevSecOps, and infrastructure drift. My name is Stefan, and I'm one of the driftctl, driftctl maintainers. It's an open source project around drift management, and I'm also working on infrastructure as code at Snyk. So in this talk, I will briefly define what is infrastructure drift, and what we learned along the way. And at the end, I will show some examples of how things can drift and what it looks like to detect that drift. It's a lighted talk, so no time for a demo this time. But basically, you will still know about the most important stuff at the end. So I think I will not reveal some hidden truth here. Cloud automation is a hot topic. More and more developers are integrating tools and solutions around infrastructure as code with all the best practices that go with it, etc. And I think that HashiCorp recently released a number like 100 million downloads for Terraform. This is huge. It's like every single developer in the world basically downloaded Terraform like 5 times or something. It's huge. So speaking of developers, it's now become very common to see developers build and deploy and run their own services in the cloud, and that's definitely for the better. And the truth is that a lot of cloud resources are still living outside that automated configuration, and it causes a lot of pain, including on the security side. That's why we're here. And that's what we call drift. Detecting it means basically gaining visibility of what's living outside of your Terraform or infrastructure as code configuration. So if you have one thing to remember from this talk, is that almost everyone is experiencing infrastructure drift, and that drifts can have major consequences, including security. That's basically why we built driftctl to help. So we had to come up with a common definition for what is infrastructure drift, and that's what we found. It's like what it happens when the reality and the expectations don't match. You can also hear it as, oh my God, when things go really, really wrong and while they were not supposed to. So basically, according to this definition, your AWS account has a ton of actual resources that's on the right, and maybe only part of it is correctly managed by Terraform. That's on the left. And the diff between the two, basically, that's the drift. So what are causing this drift? What are the causes of this drifts? So there are many causes, and the major ones are basically, obviously, the manual changes that someone makes directly on the AWS console. And you can have also everything that is authenticated. So we can find lambdas, microservices. We can find authenticated scripts, the ones that run every night to do stuff like snapshotting disks, scanning for stuff and creating an action depending on the tags, that kind of things. You can also have a different cause that is a different team working with a different tool than yours. And this is creating actual resources out of your Terraform configuration. But you can also have this AWS service that you need to use and deploy, and that are not available in the latest Terraform provider version. So maybe you have to do it manually or with a different tool. And you can have like the different projects using different cloud accounts, cloud providers, sorry, and very different from what you're used to, and probably you don't have the time to automate it properly. So all those activities and many others, basically, they share something. They are all authenticated. They do actions on your cloud provider, and they are all sources, causes, basically, of drift. But it could be no big deal. Well, who cares? And maybe we could live with all those drifts, but the problem is that misconfiguration can lead to security issues, and those security issues you don't even know about because you don't even know about the resources. So we see on this slide that the NSA recently labeled poor access control and misconfiguration as top issues. And with that, you can say that they are not even sophisticated and highly common. So you definitely want to know about the unknown stuff running inside your cloud provider accounts, clearly. So there's unknown resources. That's what we call the blind spots. There are unknown resources, those that are not under control with Terraform. Well, they are live. They are exposed. They might not be secure. We don't know. That's why we need to discover them. And only then you will know about if they are misconfigured or not. You will only you will only know about misconfiguration only by then, and only then you will be able to address or fix the issues. So I will share some examples quickly and show some code here to explain what we mean by infrastructure as code and drift and how this can happen quickly. Once again, no demo, but we'll have a few examples here. So in this case, for those who are not familiar with Terraform, we have resources to create resources on the AWS cloud, for example. And in this case, we have an IAM user, an access key, and a policy attachment. That's how basically you create an IAM user to authenticate against the AWS API with a tag, etc. You create an access key, and this key is linked to the user you just created, and you have an AWS IAM user policy attachment for this user with a policy. This policy, in this case, is read-only. So with those lines, basically, you just create an account with an access key and a policy read-only. Cool. What if you go to the AWS UI console, sorry, and basically you just create a new key? And what if you create a new attachment? You attach an administrative policy and you create this new key. If you think that by using Terraform the next time, like Terraform apply, then it's going to revert your changes, well, you're wrong. I was that guy, and it's not the case. It's not the way it's supposed to work. It's not even a bug. It's not meant to work like this. A different key is just a different key. So if you create a new key, this will never be reported. It's the same thing for a policy attachment. So in this case, if you think that, well, I will remember this on Monday and tell my team or whatever what I did, well, you're wrong. You will forget about it. Plus, no one will see it in the case of Terraform. So it's the kind of thing that can happen when you think it's going to be discovered, managed, handled, and it's not the case. It's very similar with the security groups. You have a resource called AWS security group. You create your group and you create rules with a different resource type in Terraform. In this case, YOLO, SSH on the local network. If you go to the AWS console, or you have the CLI, whatever, creating a new rule, I don't know, it can also be a service on Kubernetes or something, creating a new rule to allow something temporarily or something. And if you Terraform apply that later, it will not revert. It's a different rule. So if you write your Terraform code this way, there is a different way to do it, but this way, you will never know about it. Even worse, the rules would be, in the end, written in your Terraform state file, which is the file that is the common, the shared transaction file between your intention and the reality on the AWS cloud. So this is the kind of drifts we can have. It's the same thing with S3 buckets or whatever. We can have a lot of different settings that may or may not be seen as being different depending on the way things have been coded in Terraform. So this is just a different example here. And if you change something in this very simple AWS S3 bucket, many settings will be changed also on the state file, but not but they were not expected to, and you will never know about it. So basically, a different way of seeing this is by using a tool like driftctl. driftctl is basically scanning your state files. So if you have many of them, they are aggregated, and it's the tool scans your AWS account. In this case, to detect a drift, imagine you are just creating your infrastructure is fully automated, and imagine you are just creating manually a VM, an EC2 instance, and you do what you have to do. And if you just launch driftctl scan, boom, you will have everything that was created by this manual action on the web console. You will have an EBS volume, an instance, a security group with 2 rules. Cool. Now, if you delete that VM after you're done your test or whatever, and you launch again the drift detection, do you know what's gonna be there? Nothing. You will still have a security group and a security group rule, because for some reason AWS doesn't clean your everything that is created when you do some manual things on the web console. So this is the kind of things that make a tool like driftctl, drift detection, very important, because cloud provider accounts are filled with unknown resources, lost and abandoned stuff that are live and actually running sometimes. So basically, driftctl is a tool that can also output a beautiful report in HTML, so you can read about your drifts here and then, etc. You can also have a JSON output, so you maybe store some data in a database. You can integrate with, I don't know, dashboard, etc. You can also use it through JQ or something, like, I don't know, you might want to store your coverage, your code coverage, depending on the drift, on Grafana or something. You can filter with just for some types of resources. In this case, a security group rule, but you can have that on S3 buckets or IAM users, policies, whatever you want. I highly recommend you do this. So you can have reports and alerts like every hour or so. You can ignore stuff that are expected to be drifted, like the first Terraform user might very well be manually created. I highly recommend as well to ship driftctl in your pipeline, or at least in CI integration, so you can have like an alert when something goes wrong, or you can also have drift detection at the beginning of the pipeline for Terraform. So before your Terraform apply anything, to ensure that nothing changed before you apply a new thing, you will probably want to check everything is okay before the Terraform state is changed by this this process. And you might also want to have a scan at the end of the full pipeline, because you might have things that went wrong. You might have scripts that did something weird or something, and you want to ensure at the end that what you expected is 100% correct between your intention and the reality. So basically, here we are. That's driftctl. There's support for AWS. GCP and Azure just came in with 0.15 and 0.16. 0.17 is out probably next week. There's GitHub support as well. Terraform state can be stored pretty much anywhere. Terraform Cloud was released a while ago. Terraform Enterprise is merged like this week by a community contribution. It's cool. It's written in Go. It's open source, Apache 2 license. Please join us on driftctl.com for the website. We are all available on Discord. You can join driftctl.com/d. It will redirect you to our Discord and talk to all the developers. So if you joined during the talk and you don't know what I'm talking about, basically what's to remember is that almost everyone is experiencing infrastructure drift, and that driftctl is a tool to detect that. So thank you for your attention. Thanks for watching, and stay tuned for cool news around drift management. Bye-bye.
Okay, thank you. One thing I know now is that we have to pronounce the tool as driftctl, because there's always that thing with cube as well. Is it kubectl, kubectl?
Yeah.
At least I know that drift is driftctl, so I will not mispronounce it once again. I think we have a question from Gerald. Yes.
We do indeed. So the question is, at what stage or stages of your IAC pipeline would you recommend to check for drift?
Well, that's what I briefly mentioned during the talk. I would check, if I want to ensure everything is okay, I would check at the very beginning, so nothing changed before applying. So I'm sure that the Terraform state will not integrate a change that is not expected, a manual, something manual like security group rule, and at the end to be sure that everything is in order. So yeah, that's what I would do before and after, plus an hourly check to be alerted.
Amazing.
I think a great takeaway is to do it at these two points. That's at least something to start with, and from there you can continue and go on.
Exactly right.
Thank you, Stephane. First of all, to make sure that everybody understands what drift is, and that we have tooling for that that can help you detecting and managing that drift.
Thank you.
Thank you, and enjoy the rest of your day.